Today we're going to talk about EMF and its effect on the nitric oxide status in our body. So electromagnetic radiation, this is waves of electric and magnetic energy moving through space together. Electromagnetic fields, these span large frequencies. But what they do, they change the electrical charge, which changes biological processes in our body. In effect, increasing the quantum decoherence and loss of energy efficiency. Today, we're exposed to microwaves at levels of up to 10 to 20 times more than originally. There seems to be a lot of controversy in the literature on whether these are dangerous enough. However, these studies do not account for other environmental toxins that increase the adverse effects of the radiation. In fact, most experiments only involved one stressor under pristine conditions, and this just is not how life works. Previous oxidative stress and inflammation exacerbate this adverse effects of EMF on us. So EMF affects every single process in our body, from metabolic disturbance, cancer, neurodegeneration, increased oxidative stress, infertility, sleep disorders, neurobehavioral, cardiovascular, everything. So these non-thermal effects of EMF increase the generation of reactive oxygen species. They throw off the redox balance, meaning the oxidating and reducing molecules are not balanced, and it increases oxidative stress. Oxidative stress is antioxidant defense is insufficient or overwhelmed. This will disrupt the structure and function of cells, change electrical currents in tissue, and down-regulates production of nitric oxide. Oxidative stress plays a role in all chronic, degenerative, and inflammatory issues. So EMF increases superoxide and oxidative stress. EMF uncouples nitric oxide synthase. It activates NADPH oxidase. It uncouples mitochondrial electron transport chain. It increases activity of myeloperoxidase, increasing hydrogen peroxide. Stimulates xanthine oxidase, increasing superoxide. It stimulates the Fenton reaction, increasing your Fe3+, your ferric iron, and your hydroxyl radical. And you see iron dysregulation increase in the Irish, the English, and the Ashkenazi Jews. They have increased HFE SNPs, the hemochromatosis SNPs. EMF increases the intracellular influx of calcium, which stimulates the NADPH oxidase. Supporting the nitrate to nitrite to nitric oxide pathway addresses every single one of these factors to decrease oxidative stress. And you'll see on some gene reports a gene called CACNA1C. This is a gene that encodes the voltage-gated calcium channels. And this, when there are gene SNPs there, this increases excitotoxicity and oxidative stress. You have increased sensitivity to EMF. It's also the gene that's associated with bipolar, schizophrenia, and these have to do with that increased intracellular calcium. So these voltage-gated calcium channels, these are stimulated by EMF. They're located in muscle, glial cells, neurons, adrenals, widely distributed throughout the CNS. They allow this calcium influx into the cells. With this loss of membrane potential, it actually causes a proton leak from the mitochondria. You have decreased ATP synthesis, increased reactive oxygen species, and oxidative stress within the mitochondria. This leads to that mitochondrial uncoupling. The electron is not passed on down to form water, leads to cytotoxicity, weakens the neuronal integrity. You have a breakdown of the cytoskeleton. You have dilation of the endoplasmic reticulum. You have the cytosolic shrinkage, a net dehydration of the cell. You have activation of the NMDA receptor, which is a component for inflammatory and neuropathic pain. And it's the base of the pathophysiology of CNS disorders, including Alzheimer's, Parkinson's, and MS. So nitric oxide and nitric oxide donors inhibit this calcium influx into the cell by two different actions. You've got direct nitrosylation on that channel protein, and you've also got activation of the cyclic GMP, which increases nitric oxide within the cell. Nitric oxide inhibits that calcium current, regulates the intracellular calcium concentration, and the synaptic transmission. So nitric oxide can actually recouple that mitochondria, blunting that mitochondrial calcium overload without undermining ATP synthesis. So by looking at this, you will see that EMF affects every physiological process, from stress to learning, memory, HPA dysfunction, sleep disturbances, blood-brain barrier disruption, inflammation, mast cell activation, metabolic dysfunction, cardiovascular dysfunction, leaky gut, infertility. And here's a slide showing where nitric oxide affects every single physiological function: cardiovascular, neurological, vision, endocrine, immune. So why is nitric oxide essential? It regulates all cardiovascular function and homeostasis. It governs circulation and microcirculation. Red blood cells require adequate nitric oxide in order to deliver oxygen to the cells. Supports neurotransmitter function, regulates gastrointestinal function, including gastroparesis, a healthy mucous membrane layer, and healthy microbiomes everywhere. It helps activate the GLUT4 receptor in order to translocate to bring glucose into the cell. It's essential for learning and memory. Supports mitochondrial biogenesis. Controls the efficiency of the mitochondria in the generation of energy and the generation of hormones. This is where cholesterol first gets metabolized into pregnenolone. Nitric oxide is essential for sexual function in both men and women. It's required for stem cell mobilization and differentiation, which stem cells are required for all healing to take place. Nitric oxide tells the stem cells where to go and what to do. Regulates immune system function, regulates the inflammatory response and scavenges free radicals, modifies platelet activation and aggregation. This is a clotting factor, and this is what we're seeing in this current time. All these microclots. Supports telomerase activity, which has everything to do with longevity. So we make nitric oxide through two different pathways. One, the arginine NOS, nitric oxide synthase enzyme, oxidizes arginine into nitric oxide. It requires oxygen, and it's also pH dependent. So in most chronic conditions, you will see like a more acidic pH. Well, this uncouples this enzyme, making it dysfunctional. And then we've got the nitrate pathway, the nitrate to nitrite to nitric oxide pathway. Nitrates, you will find them in green leafy vegetables, arugula, lettuce, kale, spinach, celery, bok choy, beets, or a clinically proven nitrate supplement. By supporting this pathway, the nitrate to nitrite to nitric oxide pathway, this bypasses that arginine pathway. It is not oxygen dependent. In fact, hypoxia stimulates this pathway, and it's not pH dependent. So we consume the nitrates, they get absorbed, they circulate around, they get concentrated in the salivary glands. The salivary glands release the nitrate. We've got good anaerobic bacteria on the dorsal aspect of our tongue that will reduce that nitrate to nitrite. We swallow the nitrite. In the acidic environment of the stomach, some of that nitrite gets reduced further to nitric oxide. Here's your protection against H. pylori, but most of the nitrite gets absorbed and acts like a nitric oxide donor, and different tissues can reduce that nitrite further to nitric oxide on an as-needed basis. Like in the muscle, the myoglobin can reduce nitrite to nitric oxide. In the mitochondria, they can reduce that nitrite to nitric oxide on an as-needed basis. So as we age, our ability to make nitric oxide decreases. Us women, we can hold on to that ability a little better than men until we reach menopause, and then it kind of evens out. So by the time we're 40, our ability to make nitric oxide through that NOS pathway decreases to about 50%. By the time we're 60, it decreases about 15%. So that is why it's so essential to support that nitrate to nitrite to nitric oxide pathway to optimize nitric oxide for healthy longevity. So our ability to make nitric oxide is affected by aging. We talked about that. Diet, the standard American diet, which is devoid of nitrate-rich veggies, essential nutrients and cofactors, the lack of exercise. Medication like antibiotics, antidepressants, birth control pills, NSAIDs, PPIs decrease the production of nitric oxide through both pathways. EMFs is what we're going to be concentrating on today. Pollution, anything that increases oxidative stress. Glyphosate, genetics, and not just your NOS SNPs, anything that increases oxidative stress. Your SOD SNPs, your catalase SNPs, your HFE SNPs, anything that influences the production of BH4, your QDPR SNPs, your DHFR SNPs. If you have any MTHFR SNPs, you're by definition nitric oxide deficient. And the big one, stress. So the NOS enzyme, when it's coupled, BH4 allows that coupling. The electron is handed down from your NADPH to your flavin molecules, your FAD, your FMN, onto the iron moiety of the enzyme. This hands that electron to arginine and oxidizes it to nitric oxide. When it's uncoupled, that electron is handed down, and instead of handing it down to arginine, it hands it down to oxygen, and oxygen becomes superoxide. So BH4 is what helps this NOS be coupled. So when NOS is uncoupled, it becomes a superoxide generator, not a nitric oxide generator. So that rate limiting cofactor, the BH4, oxidative stress, oxidizes that BH4. What's kind of cool, vitamin C is the only nutrient that can take BH3 back to BH4. And without enough vitamin C, that BH3 oxidizes further to BH2. BH2 uncouples NOS. But there's other inhibitors of BH4. You've got molecules from the RAS cycle, the renin, angiotensin, aldosterone cycle, cortisol, stress, mercury, lead, aluminum. When you have BH4 depleted, uncoupled NOS, arginine can stimulate superoxide production, increasing the uncoupling. So EMF increases NOS uncoupling. So nitrate supplementation actually inhibits that NADPH oxidase enzyme, decreasing superoxide and oxidative stress. By inhibiting that NADPH oxidase enzyme, you will increase levels of NADPH. And this NADPH is needed for prevention of other chronic diseases like recycling of glutathione, steroid synthesis, fatty acid synthesis. Nitrates upregulates the production of BH4 through the enzyme GTP cyclohydrolase. BH4 recouples NOS, increasing nitric oxide, decreasing superoxide. Nitrates increase the activity of your SOD and catalase. It helps scavenge free radicals, decreasing oxidative stress. So nitrates increase nitric oxide through that pathway, recoupling NOS, decreasing oxidative stress. So EMF increases oxidative stress by upregulating NADPH oxidase. Now this enzyme is normally dormant, but is activated during respiratory bursts, and it produces superoxide, increasing oxidative stress. However, it is being stimulated by all these environmental toxins, by all these environmental factors. It's activated by mTOR, histamines, oxalates, aluminum, iron, glutamate, smoking, homocysteine, sulfites, LPS, dopamine, that RAS cycle, pro-inflammatory cytokines, mold, EMF. So you've got this EMF stimulating this NADPH oxidase, just compounding the issues going on. And this enzyme will preferentially take that NADPH, what Dr. Bob Miller calls the NADPH steal, and you've got decreased NADPH for all these other processes like fatty acid synthesis, steroid synthesis, decreased phase 1 detoxification through cytochrome P450. You've got decreased ability to recycle critical antioxidants like glutathione, decreased ability to make nitric oxide. So you've got increased reactive oxygen species by this upregulating of NADPH oxidase, which goes on to impair every single process. But the cool thing is the nitrite and nitric oxide downregulate this NADPH oxidase. This is a beautiful diagram showing that nitrates reduced to nitrite, increases in nitric oxide, inhibits NADPH oxidase, inhibiting superoxide, inhibiting oxidative stress and endothelial dysfunction, and decreasing cardiometabolic disease. So Dr. Martin Pall, who has written fairly extensively on EMF, he talks about the point that there is the EMFs increase the production of nitric oxide, increasing the production of peroxynitrite. So when nitric oxide combines with superoxide, it forms peroxynitrite. So the influx of these calcium ions can stimulate the calcium calmodulin dependent NOS enzymes, and that's your eNOS and nNOS to increase nitric oxide. And theoretically, it could increase a peroxynitrite. However, the data is severely limited on this. In fact, nitric oxide may be present. However, it doesn't mean that nitric oxide is causing any pathology. Just like when you have a fire, like the firemen come, they're always at a fire, but it doesn't mean the firemen have anything to do with that fire going on. They're there to help clean up the mess. So in general, if you're making a lot of superoxide, you're typically not making a lot of nitric oxide because superoxide shuts down nitric oxide production. And if you're not making a lot of nitric oxide, you're not making a lot of peroxynitrite. So supporting the nitrate to nitrite to nitric oxide pathway actually downregulates the three main sources of superoxide in our body. One, uncoupled NOS. Nitrite recouples NOS. Two, your NADPH oxidase. Nitrite and nitric oxide inhibit that NADPH oxidase, decreasing superoxide production. And three, the uncoupled mitochondrial electron transport chain. Nitrite and nitric oxide help recouple that electron transport chain. In fact, it's really controversial whether increased nitric oxide from iNOS or any other source is the source of injury for cells. They use a NOS inhibitor called LNAME, and they do see decreased tissue injury and inflammation. However, this may not be due to the inhibition of nitric oxide production. There's other actions of LNAME here that may be causing that decrease of tissue injury. So restoring the nitric oxide production by supporting the nitrate to nitrite to nitric oxide pathway decreases superoxide, thus decreasing peroxynitrite, decreasing oxidative stress. And I want you to pay attention when you read these studies, and they're calling peroxynitrite the molecule that's causing this tissue injury, because most of these studies are not even measuring the peroxynitrite. Actually, what they're measuring is a nitrotyrosine, and they're assuming that peroxynitrite was formed. But there's other nitrosating species that can form nitrotyrosine. This is not specific to peroxynitrite. In fact, there's a new paradigm emerging in the nitric oxide research community where this peroxynitrite isomerizes to NO3, which is nitrate and inert. In fact, there's actually some possible beneficial actions of peroxynitrite. Downregulates expression of pro-inflammatory mediators, suppresses NF-kappa B activation triggered by LPS and inflammatory cytokines, inhibits lipid peroxidation. So when superoxide and nitric oxide react, they form a cage-like molecule, and 90 to 95% of that rearranges into inorganic nitrate, which is inert. So restoring nitric oxide production decreases superoxide production, decreases peroxynitrite production. So the redox balance, so the antioxidant side, your SOD, your superoxide dismutates, converts superoxide to hydrogen peroxide. Your catalase converts hydrogen peroxide to water. Your glutathione NADPH is required to reduce the oxidized glutathione back to reduced. Peroxyredoxins, these degrade hydrogen peroxide. Glutathione peroxidase, this helps the lipid peroxides, and this is actually the major antioxidant in red blood cells. But EMF decreases the activity of SOD, catalase, glutathione peroxidase, and decreases the level of glutathione in the blood and the brain. And remember that the initial stage of this reactive oxygen species production by the EMF is controlled by that NADPH oxidase, increasing that NADPH steal. So supporting that nitrate to nitrite to nitric oxide pathway decreases the NADPH steal and increases glutathione bioavailability. Nitrate increases SOD catalase activity. Nitric oxide plays a key role in controlling levels and limiting reactivity of reactive oxygen species. This is mechanisms of the protective effects of nitrate and nitrite in cardiovascular and metabolic diseases. The nitrate reduced to nitrite, reduced further to nitric oxide, decreases peroxynitrite, decreasing reactive oxygen species. So EMFs increase blood pressure, heart rate, increases arrhythmias, enhances dyslipidemia, and stimulates that RAS cycle, the renin-angiotensin-aldosterone system. Nitric oxide governs circulation and microcirculation, and it down-regulates that RAS pathway. So nitric oxide, cyclic GMP pathways actually help close that voltage-gated calcium channel, inhibiting calcium influx. Nitric oxide regulates all mechanisms controlling intracellular calcium. So nitric oxide and those RAS cycle, they're intertwined. The renin-angiotensin-aldosterone system. The aldosterone is independently associated with all-cause mortality. Up-regulated RAS down-regulates nitric oxide. And inhibiting nitric oxide production up-regulates the RAS cycle, which increases interleukin-6, an inflammatory cytokine. This goes and stimulates NADPH oxidase, which stimulates interleukin-6. So we've got this bad, vicious cycle going on. Interleukin-6 stimulates mast cells. So nitric oxide down-regulates the RAS, down-regulates the aldosterone production and the interleukin-6. So according to the free radical theory of aging, these reactive oxygen species damage mitochondrial proteins, DNA, decrease ATP production, and cause net dehydration of the cell. So the mitochondria, they make this ATP and create the voltage of the cell. And this is in the aqueous. This is in the water. So the mitochondria make a special kind of water, that deuterium depleted water, which can carry the charge. So these mitochondria, they consume a lot of oxygen, but instead of like handing that electron off to the water, it hands it off to superoxide when the electron transport chain is uncoupled. So EMF uncouples that electron transport chain and you leak electrons. This causes oxidative damage to the membrane. You're down-regulating your antioxidant genes, your SOD, catalase, glutathione peroxidase, and it actually changes the way we handle macronutrients. We lose the ability for beta oxidation of our fatty acids. Mitochondria, electron transport chain, can reduce that nitrite to nitric oxide in hypoxia. And blue light and EMF cause hypoxia. Remember I said that NOS enzyme requires oxygen. So you're not going to get your nitric oxide through that pathway. So nitrite and nitric oxide recouple that electron transport chain, decreasing that proton leak. Nitrite and nitric oxide stimulates hypoxic mitochondrial biogenesis. It activates AMPK and SIRT1, going on to activate the PGC1 alpha. And the PGC1 alpha is the regulator of mitochondrial biogenesis. It helps protect against neurodegeneration, increases the fatty acid burning in the mitochondria. mTOR, the mechanistic target of rapamycin. So mTOR regulates cell growth, proliferation, motility, survival, protein synthesis, autophagy, activates insulin receptors and IGF-1. However, we are swimming in a sea of mTOR stimulation, like iron, MSG, pesticides, amino acids, xenoestrogens, estrogens, plastics, glucose, insulin, high fructose corn syrup, dairy, folate. All of these stimulate mTOR. mTOR stimulates that NADPH oxidase. mTOR drives cerebrovascular dysfunction by downregulating eNOS. mTOR inhibits AMPK and autophagy. And that AMPK is essential for glucose and lipid metabolism and mitochondrial metabolism. And the current virus actually co-opts that mTOR and makes the host more hospitable for replication. So studies have shown when you decrease the activity of mTOR, you actually increase lifespan. You're increasing autophagy and the cleaning up the debris, helps maintain cellular viability. Senescence is when cells stop dividing and lose their function. You've got irreversible growth arrest. And you see increased oxidative stress from the cell phones. These increase the senescence of the cells. So nitric oxide and nitric oxide donors stimulate the AMPK, which blocks mTOR and allows for autophagy, the cleaning up. Nitric oxide can prevent endothelial senescence. Nitric oxide increases telomerase activity to restore telomere length. This has everything to do with longevity. EMF causes a biological stress response in our body. It dysregulates that HPA axis. You're increasing the glucocorticoid levels, your cortisol. It impairs growth of neural cells in the hippocampus. This is where learning and memory happen. It increases heat shock proteins, and this is a marker of the cell under stress. So Dr. Klinghardt says every cell in our body is in alarm state from EMF. He gets the sickest of the sick, and when people go to see him, they all have to clean up their EMF environment. So the stress response increases cortisol. Cortisol down regulates iNOS, and that's why when we're stressed, we get sick easier. And eNOS, that's why when we're stressed, it increases cardiovascular disease, hypertension, MI, strokes. Cortisol increases oxidative stress, decreases BH4, which uncouples NOS, decreases membrane transport of arginine, increases blood glucose, increases hemoglobin A1C. Hemoglobin A1C tightly binds to nitric oxide and makes it not bioavailable to do all these good things. So all of these processes decrease the production of or make nitric oxide not bioavailable. Nitric oxide is essential in our immune response. It's our defense against pathogens. Regulates macrophages, T lymphs, antigen-presenting cells, mast cells, neutrophils, natural killer cells. It is an immunoregulator. So all the comorbid conditions leading to increased vulnerability to this current viral situation have depleted nitric oxide levels. And there's actually a lot of studies showing that this increased EMF increases our susceptibility to this viral infection. But aging, obesity, the two main comorbid conditions, depleted nitric oxide. Diabetes, metabolic syndrome, COPD, autoimmune disorders, hemoglobinopathies, all depleted nitric oxide status. So you need functional iNOS, NOS2, inducible NOS. This is part of that immune response. And eNOS, endothelial NOS, NOS3, which governs circulation and microcirculation. So Dr. Nathan Bryan, the premier nitric oxide researcher, said, well-vascularized tissues are more resistant to infections and capable of localizing containing offending agents. By contrast, poorly vascularized tissues are relatively inefficient in responding to inflammatory stimuli. So EMF is classified as an immunosuppressant, causes that biological stress response, down-regulates the production of nitric oxide. And nitric oxide is essential for our defense against pathogens. It alters that gut-brain immune axis, increases the calcium influx, which increases cytokine storms. These increased cytokine storms increases susceptibility. This EMF intensifies our reactions to mold, Lyme, virus, bacteria, parasites. Oxidative stress downregulates the production of nitric oxide. So nitric oxide is essential in the gut-brain immune axis. So in the gut, nitric oxide is essential for mucus production. It reduces degranulation and mediated release of the mast cells, reduces cytokine release from the macrophages, increases formation of new blood vessels, vasodilates, accelerates wound healing, reduces superoxide free radicals, and reduces adherence and secretion of the neutrophils. So mucus, our first defense against pathogens. It's our protective layer to balance the good bacteria and the bad bacteria. And it's exposed to many damaging substances. And stress can alter our GI motility and secretion. It increases intestinal permeability, decreases mucosal blood flow, and has negative effects on the microbiome. EMF gives a biological stress response. So supporting that nitrate to nitrite to nitric oxide pathway, you're supporting mucus production and health. You're increasing the mucosal blood flow and vasodilation. You're supporting health and biodiversity of the microbiome. EMF stimulates mast cells. So these mast cells, these are effectors of the gut-brain immune axis. They translate these stress signals into release of neurotransmitters and these pro-inflammatory cytokines. Think neuroinflammation. So mast cells line all mucous membranes and they release histamine, cytokines, chemokines, interleukins, platelet activating factors. They are activated by superoxide and they're activated in the absence of nitric oxide. So supporting that nitrate to nitrite to nitric oxide pathway, you are helping to regulate the activity of the mast cell. You're inhibiting the mast cell degranulation and histamine release, inhibiting the inflammatory cytokine release, inhibiting leukocyte endothelial cell attachment, and you're inhibiting generation of reactive oxygen species. EMF damages and impairs the blood-brain barrier. So you see a leakage of albumin, you see serious neuronal cell damage. These tight junction proteins that are in the blood-brain barrier, the eyes, intestinal tract, skin, kidney, bile duct, these are important for epithelial transport and barrier integrity. You lose these tight junction proteins and you've got a breakdown of the barrier and things get through that shouldn't get through. You see decreased expression of occludin and claudin 5. You see leaky gut, leaky brain, GI inflammation, neuroinflammation. They are all connected. So nitrate increases the rebound levels of occludin and claudin 5, which protect the tight junction proteins and barrier integrity. BDNF also affects the integrity of the tight junction proteins. Nitric oxide is an essential mediator of BDNF. EMF is considered an environmental pollutant capable of disrupting microbiomes everywhere. So it increases antibiotic resistance, enhances biofilm resistance, enhances the formation of biofilm, decreases good bacteria while increasing harmful, and beneficial bacteria grow slower. So supporting that nitrate to nitrite to nitric oxide pathway, you're going to prevent dysbiosis, support healthy microbiomes, decrease inflammatory pathways, downregulate and scavenge reactive oxygen species, and nitrite has been used to disrupt protective biofilms. So these voltage-gated calcium channels affect learning, memory, cognition. When they're stimulated, you increase reactive oxygen species, you alter the blood-brain barrier integrity, you increase neuroinflammation and neurodegeneration, you increase neuronal damage to the cerebral cortex, you see degenerative changes in the cerebellum, you see apoptosis of the amygdala, damages to the myelin sheath. This influx of calcium ions can actually trigger apoptosis. So it causes excitotoxicity, just like methamphetamine causes excitotoxicity. So these neurons are especially sensitive because they are around longer. They last longer than other cells, and they have limited renewal. So supporting that nitrate to nitrite to nitric oxide pathway in neuroinflammation, you're increasing nitric oxide directly and recoupling that NOS, decreasing oxidative stress. It's anti-inflammatory. You're down-regulating these inflammatory cytokines. Your interleukin-1b, interleukin-6, interleukin-18. You're decreasing mast cell degranulation. You're supporting microbiomes everywhere. You're supporting the tight junction proteins. So nitric oxide governs circulation and microcirculation. And if you have impaired blood flow in the brain, this will increase neurodegeneration. Nitric oxide in the hypothalamus and the cerebral cortex has to do with learning and memory. Nitric oxide inhibits that calcium influx into the neurons, which limit glutamate neurotoxicity. It's a neuromodulator, increases synaptic plasticity, increases BDNF, increases neurogenesis, increases mitochondrial function and biogenesis. When you repair these damaged cells, your survival is much better. So nitric oxide governs circulation and microcirculation, and high blood pressure is a risk factor for cognitive decline and dementia. And about 50% of the people have high blood pressure, because remember I said by the time we're 40, our NOS is only functioning about 50%. By the time we're 60, it's only functioning about 15%. So hypertension occurs decades prior to onset of dementia. The brain produces 20 times more nitric oxide than the entire vasculature, because it's so important for delivery of oxygen, glucose, nutrients, and just as important, cleaning away the debris. So impairment of the blood flow to the brain increases this risk of neurodegenerative diseases. These volta-gated calcium channels, these have a big role in the development of chronic pain. The increase of this calcium into the cell triggers apoptosis and increased inflammatory cytokines. Inflammation causes pain and tissue damage. So this increases glutamate, substance P, and NMDA activation, which is a major component of inflammatory neuropathic pain, like CPRS, diabetic neuropathy. GABA inhibits this voltage-gated calcium channel. And nitric oxide in the brain increases GABA. When you have compromised circulation, the nerves malfunction. The lack of the oxygen, nutrients, and lower energy affects the membrane potential. So nitric oxide downregulates these pain pathways, and this is how morphine helps the relaxation response, is through nitric oxide. So EMF on the reproductive system. Oxidative stress is the most recognized cause of male infertility. So it's affecting the sperm, the ovaries, the embryo, the next generation. Nitric oxide is required for the pulsatile LHRH release that goes on to release your LH and FSH, which goes down to the ovaries and testes to make your estrogen, progesterone, testosterone. These hormones stimulate eNOS, production of nitric oxide, if it's not uncoupled. And you see the two main hormones on here that actually inhibit NOS. You've got glucocorticoids, the cortisol, and the prolactin. So EMF can decrease serum T3 and T4. EMF increases cortisol, which decreases the conversion of T4 to the active T3. So there are NADPH oxidase enzymes in the thyroid. They're called DUOX1 and DUOX2. And they increase the production of reactive oxygen species, but you need a precise amount of these for the TPO to work. Too much, it doesn't work. Too little doesn't work. So nitrites and nitric oxide inhibit that NADPH and NADPH oxidase and the DUOX enzymes. So this can actually even help thyroid function. So EMF increases hemoglobin A1C in type 2 diabetes and school-age adolescents. It's called environmental type 3 diabetes. You've got increased plasma glucose, increased blood viscosity. So this is going to be a big challenge for us with all these shots, increasing the blood viscosity in these kids. We've got to take care of them. So long-term exposure to cell phones increases the fasting blood glucose, increases serum insulin. An EMF causes that physiological stress, which increases cortisol, increasing glucose. Blood sugar dysregulation uncouples NOS. So supporting that nitrate to nitrite to nitric oxide pathway, optimized nitric oxide, down-regulates oxidative stress and pro-inflammatory cytokines, down-regulates the RAS cycle, and it's essential for GLUT4 translocation. So what's really going on here? Dr. Klinghardt says the pineal gland is the seat of the soul. The pineal gland is a receiver for higher fields of energy and translate them into thought. There will be a movement driven by big compactions to take the soul away from people, to disconnect people from the higher world. And in order to do that, they have to destroy the pineal gland in people. I've followed the research on that, and amazingly, the pineal gland is the most sensitive part of our central nervous system and is highly, highly, highly sensitive to 4 things: aluminum, glyphosate, fluoride, and Wi-Fi. And we in the USA are the only country in the world that has pushed these 4 things in the last 60 years or so on everyone growing up here. So what is needed for these compounds to actually enter the brain is to open up that blood-brain barrier, and the current frequencies in the Wi-Fi world are doing exactly that. So we're poisoning the air with the chemtrails, with the aluminum, and heaven only knows what else. We're poisoning our food with the glyphosate. We're poisoning our water with the fluoride. And then we've got Wi-Fi everywhere, opening up that blood-brain barrier and allowing all those chemicals into our brain. So he says how to dull people's minds and then kill them. So this is serious. So you see sleep interference with EMF. You see a phase shifting of the circadian biology. You see a disruption of the brain activity during sleep, increased blood-brain barrier permeability, and suppressed levels of melatonin. And most of melatonin is made within the mitochondria. And we've already talked about how the EMF interferes with the mitochondrial function. But most of that melatonin is actually made in our gut. And we've talked about how EMF destroys the intestinal tract. So melatonin is a potent free radical scavenger, especially the hydroxyl radical. And I wrote all these things that melatonin does. You can read that later. But nitric oxide chemistry plays a role in that mitochondrial circadian cycle. So we lose the ability to make nitric oxide, we have disturbed sleep. In fact, one study showed constant light exposure to the pineal gland decreased the NOS activity 80% after 8 days. So you've got neuronal NOS, production of nitric oxide within the neurons of the brain that signals sleep and sleep patterns. Regulation of REM sleep is an age-dependent process involving nitric oxide. You have impairment of the nitric oxide production, a phase shift in the circadian clock, and disturbed sleep. Obstructive sleep apnea is a hypoxic nitric oxide deficiency state. You have increased oxidative stress, you're stimulating your NADPH oxidase, you're uncoupling NOS, and you're increasing ADMA, which is linked to all-cause mortality. So supporting that nitrate to nitrite to nitric oxide pathway decreases oxidative stress, recouples NOS, decreases ADMA. These voltage-gated calcium channels increase excitotoxicity. They can increase depression, anxiety, irritability, sleep disturbance. You have decreased serotonin, dopamine, and PEA. So nitric oxide is involved in the regulation of anxiety. Anxiety and depression, you see low levels of BDNF. Nitric oxide mediates the neuroprotective actions of BDNF in promoting neuronal survival, stimulates process of neurogenesis, which enhances learning and memory, plays a role in synaptic plasticity, which positively influences mood. Nitric oxide increases GABA in the brain. Remember, that also helps inhibit the voltage-gated calcium channels. Nitrates increase the production of BH4. BH4 is an essential cofactor in making your serotonin, your melatonin, your dopamine. When nitrates decrease neuroinflammation affects how we feel. So I wanted to put this up there to remind you all of these EMF effects on all of these processes in the body. And all, like nitric oxide, touches every single physiological process in our body. These are connected. So EMF contributes to a perfect storm for low nitric oxide. Age, especially over 40, physical inactivity, the SAD diet, inflammatory diet, antibiotics, antidepressants, antifungals, the azole antifungals, birth control pills. I recommend DCing the antiseptic mouthwash, fluoride toothpaste, the whitening toothpaste, anything that interferes with the microbiome in the mouth. NSAIDs, PPIs, achlorhydria, glyphosate uncouples that NOS enzyme, pollution and stress. So EMF increases oxidative stress, increasing free radicals, which damage membranes, cells, and altering physiological processes. Oxidative stress plays a role in every single chronic degenerative inflammatory condition. Oxidative stress uncouples that arginine NOS enzyme, decreasing production of nitric oxide, increasing oxidative stress even more. So nitric oxide is at the base of every single physiological process. Nitric oxide inhibits that calcium influx from the voltage-gated calcium channels, which modulates potential damage from that. So in closing, supporting that nitrate to nitrite to nitric oxide pathway optimizes nitric oxide, increases nitric oxide directly, as well as recoupling that NOS enzyme, decreasing oxidative stress. And remember, it also inhibits that NADPH oxidase enzyme, which is stimulated by EMF, causing oxidative stress. So thanks, everybody. Is there any questions?